In this lecture, we will be discussing shadows. Shadows allow us to understand three-dimensional forms. Shadows require three things to exist. We need a light source, we need an object to cast a shadow, and we need a surface for the shadow to land on. In our exercises, we will be limiting our surfaces to horizontal or vertical. We work with a standard convention based on a simple cube. We assume that our light source is at a 45-degree angle above horizontal. We define this variable as the altitude, and then we also assume that our light source is 45 degrees from parallel, so it will run diagonally from corner to corner through our cube. We also assume all surfaces are either lit or unlit. No surface is partially lit or partially unlit. Here we can see the consequence of our conventions when we look at it in elevation with our 45-degree altitude, and in plan 45 degrees from parallel. Our goal in working with shadows is to determine which surfaces are lit or unlit and to determine the shape of the cast shadows. The process begins by identifying which surfaces are lit or unlit. It will always exist in pairs. Thus, if the top is lit, the bottom is unlit. Front lit, back unlit, left lit, right unlit. To determine the shape of the cast shadows, we look at our shade line. The shade line is the line of the edges between lit surfaces and unlit surfaces. It actually makes a continuous line around our imaginary cube. Those shadows, when cast onto any surface, will be the shape of the shadow. To construct the geometry of the shadow, we work with certain categories of lines. The three categories that we'll be looking at in these exercises are vertical lines casting a shadow onto a horizontal surface, lines casting a shadow onto a parallel surface, thus horizontal lines casting a shadow onto a horizontal surface, or vertical lines casting a shadow onto a vertical surface, and then all other lines. We have certain rules that we use in constructing our shadows. A vertical line casting a shadow onto a horizontal surface will create a shadow that is parallel to the azimuth, that 45-degree angle when we were looking at our basic cube. We'll look at other conventions when we're looking at plan obliques, and later on in this semester when we look at perspective. Our second rule has to do with lines casting a shadow onto a parallel surface, horizontal lines onto a horizontal surface, or vertical lines onto a vertical surface. In both cases, the shadow is parallel to the line. A vertical element will cast a vertical shadow on a vertical surface. A horizontal element will cast a line parallel to it on the horizontal surface. And that's true of whatever drawing convention we are using, whether we're in plan oblique or perspective or orthographics. All other lines, we have to construct the shadows based on defining 2 points on a line. The length of our shadows are determined by the altitude, and we understand this intuitively. We know when we look at a photograph, when the shadows are long, we are looking at a low light source. It's either early in the day or late in the day. When the shadows are short, we know the sun is high in the sky and the shadows are correspondingly reduced. We're going to look at how to construct shadows in plan oblique using our standard cube. These have specific conventions. So the cube is now rotated at our 30-60 degree angle that we have been using in our plan obliques. When we do this, we still assume our altitude is at 45 degrees, but our azimuth will be drawn as horizontal. This really is based on a convenient graphic convention. It's easy to do because we have a parallel slide. There's nothing else particularly magic about it. It's convenient and gives shadows that help us understand our form. The first thing we do is identify the visible shade lines. Again, these are the lines between a lit surface and a shaded surface. Our top is lit, our front left is lit, our front right is not lit. And so in this view, we recognize that these three lines are shade lines. There are additional shade lines, but they are not visible to us in this view. We're going to begin by drawing the shadow of these lines. We'll begin with the vertical that touches the surface. Whenever the object casting the shadow touches the surface the shadow is on, the shadow will start at the point where they intersect. So we know that that bottom corner is a starting point for the shadow of the vertical line. We know that the shadow of a vertical line on a horizontal surface is parallel to the azimuth, and on our plan oblique, that's a horizontal line. So we know that this is the line of the shadow of that first shade line. We don't know the length. We need to use the altitude to determine its length. The altitude is the 45-degree angle. We start at the top of the line and find where it intersects our horizontal line. Now we know exactly how long and where the shadow of that first shade line is. We then move on to our next shade line. That would be the horizontal that meets the vertical. We know one point on it, the end of our first line. This is now going to follow our second rule, the rule of parallels. It is a horizontal line. It's casting a shadow on a horizontal surface, so its shadow will be parallel. In this case, that means it will be drawn at a 30-degree angle. Again, we don't know the length without the altitude. Now we have our second shade line, the shadow of our second shade line. We continue the process with our next line. We know where it starts at the end of the last one, and it will be parallel to the 60-degree edge. Again, that's a horizontal line on a horizontal surface, so its shadow is parallel. Again, we determine the length by the altitude. The final line is going to be the shadow of a hidden edge. That will be the vertical line where it returns to the bottom. That line we know is again going to be horizontal because it is a vertical line. And if we complete the hidden form of the object, we should see that it meets pretty closely to the bottom of that line. Because this is a graphic solution, it may not meet exactly. To summarize, here is our complete process. First, we identify our visible shade lines. We begin by determining a shade line that touches the surface we are going to be drawing the shadow on. In this case, the vertical line touches our horizontal surface. We go through our process knowing that vertical lines will generate shadows parallel to our azimuth, and horizontal lines will generate shadows parallel to themselves. We work our way from point to point, tracing the shade line around the object until it completes and closes, returning to the object.